Okay, in this video we're going to look at graphing the ellipse. The first thing you have to know is how to tell if you have an ellipse. What you'll see is both terms will be squared, so x and y are both squared. And then also there'll be a plus sign, so this plus sign is important. And then it can be written in this form where there's a fraction somewhere, at least one of the denominator is not 1 on at least one or both, and then it's equal to 1. So if we have the plus sign, it's equal to 1, and then we're dividing by a different number on both denominators, then we have an ellipse. Okay, so there's a lot of things we can take from this. First, the center comes from here and here, so the center is still HK. And this is true for most of our conic sections we have, or this idea holds anywhere, where if it's in parentheses, we're going to shift the opposite direction. So my x coordinate is 2 and my y coordinate is -1 for the center. Okay, let's go ahead and just put that on the graph. So we have 2, -1. Try to get that as neat as possible, and this is the center. Okay, now we have an A value, a B value, and C value for the ellipse. The A value is the biggest denominator. So it's not the first one, it's just the biggest one. So in this case, 36 is bigger, and that is A squared. And that makes B squared 16. And so A is 6, and B is 4. And you can tell which way the ellipse stretches by the A and B value, and then where it comes from. So A is under x, so we're going to count from the center in the x direction 6. So that's 1, 2, let's go ahead and get rid of that tick mark. 1, 2, 3, 4, 5, 6, so I'm at 8, and that is called the vertex. And there's another vertex, 1, 2, 3, 4, 5, 6 over here. So my vertices are -4, -2, or -1 rather. And then 8, -1. Okay, well, and then the B value will go the other way. In this case, B comes from under y, so we're going to count up 4. 1, 2, 3, 4. And this is called a covertice. And then down 4 from the center. And so these are your covertices. And we're not going to write those out. We're going to worry more about the focus and the vertex. Okay, and so this is actually enough to sketch your ellipse, as it'll go through all these points, kind of this oval shape. That's a little bit longer on the x-axis because the bigger number was under x. And then the last thing we want to find is the focus. So to find the focus, we're going to use c squared is equal to a squared minus b squared. Looks a lot like the Pythagorean theorem, except it's minus, so make sure you realize that and don't confuse those two when we get into hyperbolas next. The formula is similar but different, so just be aware of that. So c squared is a squared minus b squared. So we can find c squared by using a squared and b squared. And remember, we said a is the bigger number, and so this will always be a positive value. So c squared is equal to 20, and then c is equal to the square root of 20, which we can simplify with 4 and 5. And we'll say c is 2 square root of 5. Okay, so that is a way to actually write your focus. So we could write the focus as we start with the center, so 2 and then -1. And my focus is always going to go to the direction of the major axis, or the bigger value, the a value in this case. So I'm going to count over to the right 2 square root of 5 and to the left 2 square root of 5. Now that's a little confusing because what does that mean? Square root of 20 is somewhere in between 4 and 5 because square root of 16 is 4, and then square root of 20, and then square root of 25 is 5, so somewhere in between. So let's just count 1, 2, 3, 4, and so before 5, after 4, we have a focus, and then 1, 2, 3, 4, and then after 4, and then before 5, as far as the distance goes. And we can write that as plus or minus 2 square root of 5 on the x-coordinate, because I move left and right. If you prefer to have a decimal version of this, that's fine. One thing you'll notice about the focus, or the foci on the ellipse, is that they are always inside of the ellipse. So if they're outside of the ellipse, you've done something wrong. Okay, let's look at this other one. So if you notice here, this is not equal to 1, and so if it's not equal to 1, our method just kind of breaks down. And so the first thing we want to do is set this equal to 1, so we divide by what's on the right. Now in our problems, these should all work out to be pretty nice, clean problems. They're not going to be too funky. So 25 will go into 225 evenly, and that will leave us with 9. And then 9 goes into 25. 225 25 times, and then it's equal to 1. Okay, so this graph has, or ellipse has a center at 0, 0, and I know it's an ellipse because there's a plus in the middle. Both terms are squared, and then these numbers are different. If they were the same, we'd have a circle, which is interesting. But so that's what we have here. A in this case is 25, so a squared is 25, and b squared is 9. Remember, a is always the bigger number. So a is 5 and b is 3. And let's go ahead and find c. So c squared is equal to a squared minus b squared. So we have 25 minus 9. And so c is the square root of 16, and so c is 4. Notice that 3, 4, 5 triangle, that relationship between A, B, and C. Okay, so it's kind of nice. Everything works out evenly here. So let's get this on the graph. We start with our center. So our center is 0, 0. And then remember, the direction we stretch depends on the denominator, and then what variable it's under. So 5 came from underneath the y, so I'm going to go up and down 5 for my vertex. So that's a vertex. That's a vertex. The distance between these two vertices is called the major diameter, or the major axis. Or major diameter, I guess. It's on the major axis. So the major axis is in the y direction. The vertices are 0, and then you could write 0 plus or minus 5, or you could list them out separately, but we'll keep it that way to be efficient. And then my covertices, 1, 2, 3, I count over the distance of b. And these are covertices. This is the minor axis in between these two covertices. And we're not going to worry about listing those. And then my focus I find from counting the same direction as the vertex, or the vertices. So my focus uses a distance of 4, and I'm going to count up from the center, 1, 2, 3, 4. 1, 2, 3, 4, down the other way. And then when you sketch these, make sure you sketch them through the vertices and the covertices, not through the focus. And there you have your ellipse. We can list the foci. I actually put focus over here. That's if it's only one, because there's 2. The plural version is foci. And so this should be plus or minus 0, and then plus or minus 4. Some things to check. One, you should always check that the foci are inside of the ellipse. If not, you did something wrong. It's also a good idea to check that you counted in the correct direction. And so like on this second one, just look back and say, okay, well the bigger number was under y, and I counted up the bigger number and down the bigger number in the y direction. Over on number 1, the bigger number was under x, so I counted from the center left and right that a value.